Dear students, today we'll see the MCQs on the subject Fundamentals of Electrical and Electronics Engineering, and in that we'll see the MCQs on Unit 1, that is Electrical Safety, and this will be the fourth part of it. So let's start with the first question. Which of the following should be used to disconnect power to electrical equipment before servicing? So the options here are screwdriver, pliers, circuit breaker, and hammer. If you read the question, it is asked that which are the following should be used to disconnect power. Circuit breaker, that is option C, is the right answer, which can disconnect power to electrical equipment. So here we can have the reasoning. The correct answer is option C, circuit breaker. Disconnecting power using a circuit breaker is a safer method as it is specifically designed for this purpose, allowing for a controlled and efficient interruption of electrical power to the equipment being serviced. Using tools like screwdrivers, pliers, or hammers for this task is not recommended and can be dangerous. So here if you see which of the following should be used to disconnect power to electrical equipment before servicing, then the right answer is option C, that is circuit breaker. Then we'll go to the next question. What is the purpose of a surge protector in electrical systems? The options are to regulate the flow of electricity, to protect against voltage spikes and surges, to increase energy efficiency, to generate electricity. So out of these options, option B, that is to protect against voltage spikes and surges, is the right answer. And for that we can see the reasoning as the correct answer is option B, to protect against voltage spikes and surges. A surge protector is designed to safeguard electrical devices and equipment from voltage spikes and surges. It works by diverting excess voltage to the ground, preventing it from reaching and potentially damaging connected devices. Surge protectors are commonly used to protect sensitive electronic equipment such as computers, TVs, and other devices from harmful effects of power surges. So with this logic, we can say that the option B is the right answer. What is the purpose of surge protector in electrical systems? The purpose is to protect against voltage spikes and surges. Then we'll go to the next question. What is the purpose of an electrical safety sign or label? So what is the purpose of an electrical safety sign or label? The options are to indicate the voltage level of an electrical system, to provide instructions for using electrical equipment, to warn of potential electrical hazards, to indicate the energy efficiency of electrical devices. So whenever we see any safety sign or label, the main intention is to warn of potential electrical hazards. So option C will be the right answer here. And for that, the reasoning is the correct answer is option C, to warn of potential electrical hazards. The purpose of an electrical safety sign or label is to communicate warnings and information about potential electrical hazards. These signs are essential in ensuring the safety of individuals working with or around electrical equipment. They may include symbols, text, or both to convey important information regarding the risk associated with electricity, and they help raise awareness about safety precautions that need to be taken. So with this, we can conclude that the purpose of an electrical safety sign or label is to warn of potential electrical hazards. So option C is the right answer here. Then we'll go to the next question. Which of the following is not a safe practice when working on electrical systems? Options are working alone without supervision, using insulated tools, turning off power before starting work, using proper personal protective equipment PPE. So out of this, working alone without supervision is not a safe practice when working on electrical systems. So here you can see option A, working alone without supervision is not a safe practice when working on electrical systems. Working alone increases the risk of accidents, and having supervision is important to ensure that proper safety measures are followed and assistance is available in case of emergencies. So with this, option A is the right answer here. The which of the following is not a safe practice when working on electrical system? The option is working alone without supervision is not a safe practice. Then we'll go to the next question. What does the term ground fault refer to in electrical systems? The options are a connection between a live wire and the ground, a circuit with no electricity flowing through it, a damaged electrical cord, a short circuit. So out of this, the option A, that is, it is a connection between a live wire and the ground, is the right answer. It is a term called as ground fault, and it is referred as ground fault in the electrical systems. So here option A, a connection between a live wire and the ground, is the correct answer. The term ground fault in electrical systems refers to an unintended connection between a live, which is called as hot wire, and the ground. This connection can occur due to various reasons such as damaged insulation or faulty wiring, and it can lead to a short circuit posing safety risks. Ground faults are a concern in electrical systems, and they are typically addressed through the use of protective devices like ground fault circuit interrupters, GFCIs. So here, what does the term ground fault refer to in electrical system? It is a connection between a live wire and the ground. So option A is the right answer. Then we'll go to the next question. Which of the following is a safe practice for storing flammable materials near electrical equipment? Options are keeping them in close proximity for easy access, storing them in a separate designated area, ensuring they are properly labeled, using metal containers for storage. So out of this, the option B, that is storing them in a separate designated area, is the right answer. So here the reasoning says that option B, storing them in a separate designated area, is a safe practice for storing flammable materials near electrical equipment. This helps minimize the risk of a fire spreading to the electrical equipment and reduces the potential for ignition. Keeping flammable materials in a designated area allows for better control, proper storage conditions, and helps in implementing safety measures. So with this, we can say that option B is the right answer. Which of the following is a safe practice for storing flammable materials in electrical equipment? The right answer is storing them in a separate and designated area. Then we'll go to the next question. What is the purpose of regular electrical equipment inspections? The options are to increase energy efficiency, to ensure compliance with safety regulations, to generate electricity, to reduce the risk of electrical fires. So if you observe these options, the more appropriate answer from these options will be to ensure compliance with safety regulations. And for that, we can have the reasoning as option B, to ensure compliance with the safety regulations, is the primary purpose of regular electrical equipment inspections. While inspections may also contribute to identifying and addressing issues related to energy efficiency, the main goal is to verify that electrical equipment is in compliance with safety standards and regulations. Regular inspections help detect potential hazards, prevent accidents, and ensure the overall safety and reliability of electrical systems, ultimately reducing the risk of electrical fires and other safety incidents. So with this, we can conclude that the purpose of regular electrical equipment inspections is to ensure compliance with safety regulations. So option B is the right answer here. Then we'll go to the next question. Which of the following is not a recommended practice for electrical safety? So the options are keeping electrical devices away from water sources, reporting any electrical hazards or malfunctions immediately, using damaged electrical equipment, following manufacturer's instructions for electrical devices. So if you see the question, which of the following is not a recommended practice for electrical safety? And if you see these options, the more appropriate option will be using damaged electrical equipment is not recommended practice. So here you can have the reasoning as option C, using damaged electrical equipment is not a recommended practice for electrical safety. Using damaged equipment increases the risk of electrical hazards such as shocks, short circuits, and fires. It is important to promptly replace or repair any damaged electrical equipment to ensure safe operations. The other options, keeping electrical devices away from the water sources, reporting hazards immediately, and following manufacturer's instructions, are all recommended practices for electrical safety. So here the answer is option C. Which of the following is not recommended practice for electrical safety? Then the option C is the right answer, using damaged electrical equipment. Then we'll go to the next question. What does the term short circuit mean in electrical systems? Options are a circuit with no electricity flowing through it, a circuit with too much resistance, a connection between 2 points of different voltages, a low voltage circuit. So out of these options, option C is the right answer. It is a connection between 2 points of different voltages. So here you can see option C, connection between 2 points of different voltages is the correct definition for short circuit in electrical systems. A short circuit occurs when there is an unintended connection, typically a low resistance between 2 points in a circuit with different voltage potentials. This can lead to a surge in current flow, potentially causing overheating, damage to equipment, and in some cases posing a fire hazard. It is a common electrical fault that needs to be identified and addressed promptly to ensure the safety and proper functioning of the electrical system. So here, what does the term short circuit mean in electrical system? The right answer is it is a connection between 2 points of different voltages. So option C is the right answer. Then we'll go to the next question. The earth, water, concrete, and human body are all conductors of electricity. Whether this statement is true or false, obviously it is a true statement. The correct answer is option A, true. Earth, water, concrete, and human body can conduct electricity to some extent. However, the conductivity varies among these materials. While metals are good conductors, materials like earth, water, and the human body have lower conductivity but can still allow the flow of electric current to some degree. So here, the earth, water, concrete, and human body are all conductors of electricity. It is a true statement. They can conduct electricity. So the option is option A, that is true. Thank you, students.